Hi, everyone, and thank you for the invitation. It's always nice to be here at ClueCon and get the opportunity to learn so much from these great people that are making it possible. A little bit about me. Lucas already gave a nice introduction. I've been working with OpenSIPS for almost 10 years now, and I pretty much I'm a developer there and also help with various platforms and consulting work that we do at OpenSIPS Solutions. And today I will be, one second, let me reset the timer here. There we go. I'll be giving you an update on what's been happening in OpenSIPS in the last year, what we've been working on, and kind of what we see the direction to go with for this release. Because if you haven't noticed the pattern yet, we try to come up with a theme each year. We push out a new release. And this year it was this nice bundle of acronyms, right? IM, MSRP, RCS, UC, IMS, right? And we'll kind of see what we did in each of these areas, as well as other features that I hope to have enough time to talk about. I've got a lot of slides. So kind of a high-level overview on how the RCS deployment is being seen right now. This is a study from Juniper Networks in the first half of this year, and they say that they foresee the market, the RCS subscriber market, to grow pretty wildly in the upcoming years. Up until 2026, it will reach 3.2 billion. So that, coupled with some other suggestions from various community members and all that, and made us choose the topic, right? Because first of all, instant messaging had been quite neglected during all of these years, right? We had the message method support, and that was pretty much it. It is becoming more and more important with the emergence of RCS, and also having support for the advanced communications with advanced messaging will also be useful for unified communications. And this is, hopefully you can see the fonts here, but this is kind of a high-level overview on the areas and the modules and kind of server applications that we've architected for this release, and I will be touching on each of them throughout the presentation. So first we'll start with the work we did with IM, and then on the UC side, and also we pushed things further a bit on the IMS as well. So first with the instant messaging, typically, as I was saying, we had sorry for the pops, we had the pager mode support since forever, right? This is maybe early 2000s since this RFC was written. It's kind of a standalone messages, right? Just SMS and no state in between. That's how a message like that would look, right? That's what we had. But with RCS, there is a need for more. There is a need to establish a session that enables you to have more sophisticated services, such as read or write receipts, right? Let me go to the next slide. Here we see right, you have your group chat. By the way, this is RCS. It's not WhatsApp. So it's kind of, you can think of RCS as a turbocharged SMS, right? You already have it, so it's going to be bundled in your phone. There is no need to install any application. And like on the Android side, it's being supported, like Google is pushing it forward. And maybe on the Apple side, it's kind of being discouraged, right? Because Apple has the iMessage application, right, which is the WhatsApp equivalent. And if they were to push things forward on the RCS side, it would be counterproductive for their iMessage. So they don't support RCS anyway. So this is, I think it's Google app. And those are read receipts. And also all the stuff we see on the OTT apps like WhatsApp and these kind of apps, they will be fully transferable to RCS applications like native group chat, native file transfer, photo sharing, and all that stuff. And all of this is done through this MSRP session protocol. Sorry. If you see in the diagram, it's established with a SIP invite. So it's like a normal call. Let's take a look. I'll skip over this slide. Yeah. So we have an application SDP, and we have some subtle differences in there, like an MSRP URI, and some session IDs, and the participants establish these sessions. And once it is established, they will proceed to send MSRP packets. For example, here it's a send method, and that is how an MSRP message would look like. Hey Bob, are you there? And on the OpenSIPS side, we kind of broke it down. So this is an implementation, some implementation details. We broke it down into a few layers. So towards the bottom, you have the protocol level, right? Just like we have Proto, TLS, WSS, SCTP, all of that. Now you will notice in the OpenSIPS 3.3, Proto MSRP. And on top of it, there are a couple modules. One is the relay. Then there's user agent, and building on top is a gateway. I will go through each of them and just kind of run you through how they work. So with the relay, it solves the problem of having to do digest authentication. This is a kind of it's in the MSRP RFC that you have to do this. If you're relay, and the module gives you these nice hooks into the OpenSIPS script on, let's say, the ingress, right, where you have to do the authentication. That is the MSRP auth route. And going even more specific, it's just like subscriber authentication. So if you've done that with the right www challenge functions and provisioning, that will be the same code is being reused for this authentication as well. So you should be comfortable setting it up. And on the egress, there is also a route helping you take decisions and giving you access to the message that is being sent out. So that's the relay. On the user agent module, we give you the necessary hooks and API functions to start sessions, manage them, both from the OpenSIPS script and let's say externally. Maybe you have, let's go maybe through a call flow, and this you'll understand better. Maybe you have a web application that is not MSRP based, right? And it's trying to reach a WebRTC client that is MSRP. So for this, we would use the MI interface to start the session, right, on the outbound leg, and then OpenSIPS, the user agent module, takes care of establishing the invite, the 200 OK, and now we have the MSRP session with the WebRTC client. And now when your web app, right, the users type the message, each of them is translated into this MI function that on the other leg is nicely transferred converted into an MSRP send, and so on and so forth. On the other direction, obviously the send messages will be converted to, not that obvious, into events that you can capture in your OpenSIPS script, so you can feed them back to the application. And towards the end, we need to end the session, so that is the end session function. So on the other direction, right, where we try to contact the application coming in from the MSRP client side, This time we have a script function, which is the MSRP UA answer, which takes care of establishing the session, right? Because you have an invite in your script, pretty much. And it is MSRP based, which will also raise this session new event in the script, so you can contact the application. And of course, on the other direction, it's the other slide, right? We send the message, which gets converted to MSRP send. So that is with the user agent. And you might have noticed there is also a gateway in there, the MSRP gateway. So the idea with the gateway was that we would like to offer the possibility for you to also hook in the the SIP clients which don't handle MSRP, right? Which simply do like regular message-based SMS. So we wrote this module that converts these clients into MSRP sessions. So it's kind of an interesting concept. Let's see how a flow would look like. So let's say these clients send us a simple message which needs to be converted into a session. It's kind of an interesting problem. So when we get this message into the script, we invoke this message to MSRP function, which opens up a session on the other side that is being internally managed by OpenSIPS, such that when they send more messages, it's transparently being pushed. The session is being looked up. It pushes messages into the session, and on the other direction, we convert MSRP sends back into messages when relaying to the, let's say, simple page mode client. And there is a problem of detecting how do we close this session, right? Because the client will just stop sending messages. It doesn't have any way to, like any specific way to stop it, so, or to indicate that it wants to close the chat session. So we simply close them based on inactivity. When they stop sending messages to that peer, the session will be closed and the buy will be automatically generated. On the other direction, now we have to convert a session coming in from the MSRP client side. We use this MSRP gateway answer function, which converts the MSRP chat messages into regular page mode SIP message packets. And towards the end now, now that we are coming from the MSRP client, it can send a buy, right? It can manage the session and close the chat. And this one is a graceful termination. It's on demand. So that is on the MSRP work and instant messaging. And this brings me to the UC, right? If you remember, to the UC enhancements area. And here we made some additions to the call center module. We basically transform it into we like to call it a contact center. Technically, the module is still called call center if you look in the source code, but now it has these capabilities of supporting multiple communication types for the agents. And moreover, since there is this idea that an agent, right, they can only handle one call at a time, right? You cannot do more. But with chat, why can't they have 3 chats open at the same time, right? In like a call center agent. So we added support for that as well. So they can do, for example, 3 or 4 chats. But also they could not do too many at the same time. So we added these. Let me show you this diagram, right, where we have all kinds of clients sending traffic, whether it's SIP messages, regular, or session mode with MSRP. You might have RCS clients coming in and right? It's an entire ecosystem, and they all push these calls and messages into the call center queue. So now it's a bit of an algorithmic problem where you have to balance and select the proper agents based on their available slots and that kind of stuff. So here, for example, we have 3 pending chats. They're in red, right? They are MSRP chats. All of them are calls, right, to some degree. They're just SIP invites. But some of them are audio calls. So now, for example, this is the balancing mode. OpenSIPS will just select and balance each call to each agent. But this might not be desirable because it may lock up too quickly the agents which have call capabilities, right, by giving them a chat each. So now they aren't able to take a call. So we came up with a full load balancing mode where here, if we have those pending chat sessions, we just throw them out to the first agent here, right? And then now the remaining agents are able to take up all the audio calls. But also you could argue that this is not ideal either because now agent 1 is too loaded while agent 4 is too free. So, we also gave you the option to just do it yourself. So there are some management interface hooks, so you can fetch the list of agents, right? See how many of them are free, what kind of slots they have, and then you can fetch the list of queues. I mean, these are already there, these commands, the list queues. But now we gave you this, sorry, my font is too small here, the dispatch call to CC agent function where you decide how the queue is to be consumed. Moving on to the IMS and third area we touched on. Our first question was what do we have to do with regards to SIP in order to have support for RCS? And it turns out that RCS actually doesn't have that many requirements, or there aren't that many like new SIP specifications tied to it. It is pretty much basic stuff that we already had, and a bunch of feature caps. If probably you're familiar with that, feature capabilities, which is honestly just a SIP header. So we support all of that already, but we gave it some thought, and maybe there wasn't that much easy control over these capabilities. So we, I can't remember if we specifically added anything, but we just documented everything as part of a blog, or how to mangle these. It's just string management. For example, when doing kind of an interconnect between RCS providers, each OpenSIPS will advertise using options the RCS capabilities it knows. So you will probably need to do some programming to mangle that header. But anyway, that's there pretty much, the whole support. And we also gave diameter some attention, and we now gave you the capability to build custom diameters from the OpenSIPS script. Not sure if you're familiar with the work done in 3.2 on the diameter side, when we added kind of the first integration with the lib free diameter project, exposing authentication and accounting via diameter messages. Now we extended that support to the point where you can build custom diameter messages. You can build, if you check out the OpenSIPS Summit presentation, there is one in which we do like a 3GPP SH application message. We build it from the ground up. So that is on the IMS and UC and all of that work and focus and central part of 3.3. But why not get into some other additions that we worked on, which first we did some some addition on SDP mangling, and this is definitely a corner case, but who knows, it might come in handy. So there is this new back-to-back SDP demux module, which sounds pretty complicated, but actually it is just solves the problem where you want to send a SIP invite to a SIP session recorder server that does not support multiple audio streams. So if you take a look here, right, that is an SDP with 2 streams, and this module simply helps break down, right, demultiplex that call into 2 calls, such that the thing will work. So, and also takes care of managing those call legs and all of that. There is some presentation. Actually, you might have heard of this module with the 3.2 release, but it was actually just on master branch back then. It wasn't on 3.2. So now it's where it finally became stable. And there were also, speaking of SDPs and mangling, there was some work done on the back-to-back module, which now natively integrates with the RTP-Relay module. So there is no need to do all of that, nitty-gritty work on the script level. By the way, do you guys know about the RTP-Relay and what it's all about? Just to make sure, could I get a, yeah, right? Because it sounds, wait, we have RTP engine, RTP proxy, media relay, right, from AG projects, and now there is this RTP relay, what it's all about. Okay, so the idea behind that, it's just a wrapper module. It kind of just makes it a lot, so wrapper over RTP proxy and RTP engine, right? There is this higher level RTP relay module that makes it easier for you to script things. There was this problem of, for example, you establish the session, right? And that alone is cumbersome. You have to give it the proper flags on the invite, give it the proper flags on the 200 OK, and then remember them because there might be a re-invite, right? And you have to also do the same flags there, otherwise things will break. So all of that now is being done behind the curtains if you just use RTP relay. And the cool part is you can flip-flop between RTP proxy or engine, right? The same code will work. So it might be cool for you to look into that. We also added this completely new status and reporting interface, which could help with automation or maybe building like nice web interfaces that give you some idea over what is going on, because lots of people, complained, or maybe not really complained, just brought to our attention the fact that I don't know what's going on with the reload, right? Is it still going? Has it finished? Can I send traffic now, or when is the right time, right? So the status report will provide this will solve this problem. I mean, not fully now, right? I mean, we just started adding some events into it and reporting, but as we go, we will keep on building upon it. Yeah, so it uses these identifiers. For example, let's take an example like derouting, right? You get an identifier for each partition, which you can then query for status. Okay, so here's some examples, right? You get data available, aggregated, running, or you can query for reports. And it's configurable here. By default, it will remember the last 20 events happening on that specific code base. For example, here we want to list reports from the core, right? This is OpenSIPS initializing, and then a couple seconds later completed, and it's ready. Here is with a reload. It says when the reload started, when it completed, and some stats about the gateways and carriers, and some useful information there. Also some work on the TCP layer, where we gave you more flexibility to fine-grain control the connections taking place. For example, back then, I mean, before 3.3, you would only set some global parameters on the TCP connections once, and that would be it. But now you can take it to each connection level. For example, here we have a setup where we got connections which are close to us, so we'd rather have a small timeout, and connections which are far apart, so we would like those to have a larger timeout, right? Fine-grained control. So we bundled all of those parameters into this TCP connection profile, and now you can just write DB entries with a profile and associate them to either one server or more servers on that kind of stuff. And last but not least, we had this security audit that made things all the more stable, and we helped discover a lot of crashes in there, and all the fixes are pushed. So I would like to thank all the community for contributing to that huge effort. There is a list of bugs if you want to run through them, published. And I would like also to give credits to my team and for all the work done there. Like, I didn't work that much on the MSRP side. It's mostly Vlad and Bogdan, so kudos to them. So yeah, that was it. Let me know if you have any questions, and thank you.
No, you got it.
Hey, thanks. Interesting presentation. Are there any production deployments for this feature yet that you know about?
So with MSRP part,
Yeah.
Not yet. We are still kind of what we did with Diameter, right? Where we started the discussion, we pushed the first version of the support, and now let's see some feedback, right? Is it enough? Is it? So we're kind of doing the same thing with these parts as well, because there isn't. It is strange when you don't get kind of a specific, requirements to implement, right? It's you never know what to go. You kind of have to explore. So that's how it is. So it's, yeah.
Cool. Thanks.
All right.
Well,
Oh, okay.
Did you have issues with TCP fragmentation, since we're talking about MSRP? And did you test with, I don't know, real devices and all that?
Yeah,
Or other, let's say, other voice over IP servers?
Yeah, that's a good question. As far as I know, I'm effectively being a relay over here. We tested with like just select few open source clients that handle MSRP to begin with, because many of them don't. So for example, we used Blink from AG Projects. That one kind of was good enough to get things tested. But yeah, as far as kind of a server to server test and all that, I'm not sure we have yet to fully stress test it, let me say. And also it's worth mentioning about the chunking support in MSRP, and that is still on the roadmap, I think. So we have to build it into. Yeah. That could come useful, for example, with the file transfers, which when you get large volumes of data, you need to push through TCP. So, okay, so thank you very much again.